We're back, and this time we're almost near the end. We are now moving into Unit 2.8. We're still in Unit 2, Section 8. We have one more unit after that, 2.9, and we'll be done. So let's look at Unit 2.8. So what am I looking at here? Well, first, let me get all this stuff out of the way so we can focus on what we're trying to look at. So we're looking at the wrapper classes again. Integer uppercase I and double uppercase D. The integer class wraps an int inside and the double wraps a double inside. So we have this idea of an object with a primitive wrapped inside of it. Not a big topic about these wrap classes, autoboxing and unautoboxing, the ability to change from the primitive to the object and back. It's done automatically for us. Okay, so we treat these as if they were these, and we treat these as if they were these. It doesn't mean they are the same things. Okay, it's just that the Java language, this was quite a number of years ago, introduced this concept such that programmers don't have to worry about converting back and forth, because there was a time when you had to do that, but now we don't. And of course, we're going to be looking at instantiation again, using the keyword new, making objects, and calling methods. Here's the deal here, though. Remember that quadratic solver? What if I wanted to make this with double objects? Not double, double objects. Is that possible? Let's try. So I'm going to say quadratic solver, instantiating. I'm going to call it S just for simplicity here, and I'm going to say new quadratic solver. Okay, I know I could make a default one. I don't want to make a default one, so I'm going to make another one. I'm going to just copy this and make another one. So now, let me call this S1. So now, or S2. So now we have two of these. I'm going to say, let me make them with double objects. New double. This is called an anonymous object. It doesn't have a name, but I could do it. So 1.0, new double negative 2.0. I'm using the same example that we did before. New double 1.0. Voila! Possible. You might be saying, wait a minute. A double is not the same as a double. Let me just remind you. Here. So we're looking at the quadratic solver. It took all primitives, A, B, and C. Yet I'm using all objects, A, B, and C. No error. Strange. Let me go and try this with integers. How about if I say new integer? Integer. I know at this point you're thinking, you got an error. Nope, not so fast. I know that's an integer, so it can't be a double in here. Can't be a double in here. Voila! That works. This is weird. This gets even more weird. We just said you need double primitives, but yet we're using integer objects. Isn't there a problem here? No, there is not. That's what autoboxing and unautoboxing means. If I put a double object, it's going to turn it automatically into a double. If I use an integer widening conversion, see, I'm getting all this is a little step deeper here. Widening conversion. It turns the integer into an int and then takes the int and widen from 4 bytes to 8 bytes. So all of these instantiation gives the same 1.0, negative 2.0, and 1.0. To prove that's true, let's do a print. let's do a print. I'm going to do print ln because I'm going to get both on the new line. Let me do s dot print solution. Oh, have a problem here. Yeah, did it again. Yeah, this prints. So that print can't go inside of a print, right? We can't have a print in a print. What are you doing? Print in the print? That doesn't make sense. We just say print. Same is true for S2. So let me do that. And now let's just see if we actually get the same thing. So I'm going to run this. And all the stuff we had before, we're going to the end. Here we go. The answer is 1, 1. Just like before, the answer is 1, 1. So you see, these things get a little tricky. You really have to pay attention as to what's happening. The conversion, the auto boxing, on auto boxing, the concept of widening and narrowing. You got to keep those things in mind. They're going to show up on quizzes, so really focusing on these. So yes, I could make a quadratic solver using objects. Moving on. We're going to look a little bit more into these wrapper classes, integer objects and double objects. So I'm going to open this up right quick here and go down here a little bit and see where my ending piece is. So I have this stuff. So I'm going to kind of bring some old things back and some new things and so on. So first of all, it says to draw the console output for this. But before we do that, let's just take a look here. I created an integer called x. Okay. And this integer was created using an instantiation of an integer object. I then created an integer called y, and I used x to make the y. Integer and double are immutable. We said that before, just like strings. So this statement might make you think shallow copy. This is where you get to, sometimes technical stuff gets a little bit more in depth when all these little things start raising up and you start wondering. That's not a shallow copy, okay? And I showed you that with a point. If you don't remember, I did a point and then I made this point, set it to that point, I do an assignment, and that's not the case, okay? This statement is going to do this. Like I said, sometimes it does things for you, sometimes it does not. Every time I do this, you're going to make a little note for yourself. This is going to do this. That's because they're immutable. They can't change. So I am going to, the point was not immutable. I could change the point. But this one is. So it does not make a shallow copy. Instead, it makes a deep copy. It actually creates a new one. So, auto boxing on auto boxing. This should not have been possible because this is an object and this is an int. How could I add an int to an object? That should not be happening. Once upon a time, this was not possible. Okay, and the only way to do that, we had to unwrap the object, get the integer value, and then add 4 onto it, get an answer, and then make a new integer out of the answer. That used to be way back in the day. I'm giving away my age here. So because they came with auto boxing and on auto boxing, when I do this, what it does is it takes the integer object, it takes the int out, adds 4, get an answer, make back the integer object because it's assignment, and store it back in X. All of that happened with just this little statement. Same is true here with y. Y, who is an integer as well, and he was the original value of x, which was 2, and we add on 10. And then we add the y value to the x, and you could see all of that. And so what we're going to do now is run this. I have some other code down here, so we're going to have some other output, but we're going to focus mainly on these. Then I have these two things printing, and then I also have print x dot equals y, meaning after all this is finished, are these two values the same? Let's just run this, and we're going to find that specific area here. So we're looking for the x and the y. So we did all that before. And here they are. After we printed the 1 1s, here they are. X was 1. X was the first one, excuse me. X was the first one, which is 6. and y is 2. Well, let's see if that's true. Yeah, well, x started off as 2. We add on 4, it became 6. Y is still 2 because we made a new integer called y. And then we add 10. So y obviously changed to 12. X is still 6. And then we changed x by adding on what y is. And y was 12. We add on 6. It became 18. So that's why this was 18 and 12. One thing I want to show you here is the old way. You see, this x.int value and y.int value is once upon a time you had to do that. This was unwrapping. This is saying from the object, get me the int value. It's a getter. You used to have to do this in order to do all this. So I had to do x.getInt value, add 4, make that a new integer, put it back to x. That was a lot of coding just to do that simple thing. So to change this, add the auto boxing and on auto boxing so we don't have to go through that. So these statements up here actually look like this. And are these two things the same? No. One is 18 and one is 12, so it's false. Okay. So moving on, example 6, draw the console output again. It's a tricky one. Look at this one. It says make a new double 3 and make a new double with 3 and do a C++ minus D++ post incrementing. So yeah, it should not be able to do this because this is a double, right? But auto boxing and on auto boxing will take care of that for us. So add this is after the subtraction, right? After the subtraction. So we have to subtract, then add. And then we look at 7. It says equals. Are these two equal? Equal versus dot equals. Okay. So this one is asking, is this the same object as this? The answer is no. So this is false. This dot equals is asking, does this double hold the same value as this double? See, these two are different. Okay. And the way I'm going to say it right now is if you're comparing two primitives, equal. If you're comparing two objects, dot equals. That's literally it. Primitives, equal, objects, dot equals. Okay? So this should be false true. And then we have these maximums. What's the maximum integer? And what's the maximum minimum integer up here, and maximum integer here, and minimum double and maximum double. We could print these and see we did this before, but I just want to remind you that these are static calls, and they're not necessarily a call to a method, it's a call to a constant. Okay, and now we have the last piece down here, which is saying we have a string, but the string itself contains a number. And if the string contains a number and we want to turn it into an integer, we could do that. But look how weird this is. Integer.parseInt. Take this string, which is a number, and turn it into an integer and store it, 4 bytes. Then we have this double, and we do the same thing, double.parseDouble. This is all working with these wrapper classes. They have a lot of nice, neat methods. Of course, this has dot double value. So cost of the dot double value. I should say not here, but here. If we were to wrap this around like this, I could say dot. Should I store it first? Let's see. I'm going to store it first. I'm going to store it as first. So let's say we had this double. DC dot double value. I just wanted to show you that because I showed the int value up here. How do you unwrap the double values? How you unwrap? No, I'm not doing that per se because I'm using the auto boxing. So you just use them as if they were ints. So you treat them as if they were ints and you treat the doubles as if they were doubles. I'm going to run this and then see what we get. Take a look at everything. Let's just find where we are. A lot of stuff here printing. We figured out these things here, and this gave me 0 because what it did do is subtract 3 minus 3, got me a 0, right? And so that means print a 0. right here. This the C and D changed though. They became 4. So when we come here and it says are these two things equal, it says false because as the C is a different object to D. It's true, they both hold the value 3, but they in themselves are two different objects. It's very much like geometry with congruent. Okay, you can't say two things are equal. For example, two lengths. Okay, they're not the same length. They may be equal measure. Okay, that's different. So we call that congruent. So these two here are not the same objects. They're two different instances of the class. They just happen to hold the same value. This one here is asking, do these two different objects hold the same value? And the answer is true. And then eventually we have these prints, and we saw these before. And then we have the cost and stuff being printed here. Now, you treat them as ints and doubles. So no need to think of this per se. I mean, this is good to store, but you could actually just print this and get the solution that you're looking for. So this is wrapper classes. We've done some before. We kind of wrapping up this section, so we're going to look at them again. These are important to know because sometimes questions are going to be given with doubles, uppercase, sometimes with lowercase, and same here. And you got to be able to know that you could kind of work in between, right? You could go from one to the other seamlessly without thinking too much about it. Now, sometimes some structures that we're going to do are going to be requiring only objects, okay? And when we get to that, I'll talk about auto boxing on auto boxing again. So we're going to see this again, okay? That brings me to the end of 2.8. That's a wrap.